A cycloconverter is a direct frequency changer that converts AC power at one frequency to AC power at another frequency by AC to AC conversion without any intermediate conversion stage. Usually, when we want to convert an AC supply at one frequency to another frequency, then we need to convert AC into DC by controlled rectifiers, then DC to AC by using inverters. This intermediate stage is eliminated by using a cycloconverter simply. Cycloconverter converts AC, a fixed one, to AC variable at different frequency. This is again two types, that is step down cycloconverter and step up cycloconverter. Here the frequency is stepped down with reference to input. Here the frequency of the output is stepped up with respect to input. Again, these two cycloconverters have two configurations. There is center tapped transformer configuration and second one a bridge configuration. Now this is the circuit diagram we use for midpoint or center tapped cycloconverter. The same circuit can be used for step down and step up cycloconverters. In step down cycloconverter, we use natural commutation to turn off the thyristors, whereas in step up cycloconverter, we use forced commutation. We have taken a 50 Hz single phase supply. First, we'll see how to step down this frequency to 12.5 Hz to step up into 100 Hz by using the same circuit. To step down 50 Hz into 12.5 Hz. Now we have 50 Hz frequency at time interval of 2 pi. One cycle is completed. Then for 12.5 Hz, now one cycle should be completed by 8 times. Frequency is inversely proportional to time. So this is 4 times less than this should be 4 times more, which means from here to here one wave should be completed, in which half of the time up to 4 pi half cycle should be there, and from 4 pi to 8 pi another half cycle should be there. Now in the positive half cycle, that is from 0 to pi, if you observe, the A is having more potential than the B of the secondary winding of the transformer. The P1 and N2 are forward passed, P2, N1 are reverse passed. From pi to 2 pi, that is negative half cycle, B is more potential than A, where P2, N1 are forward passed and P1, N2 are reverse passed. So we can use P2 or N1 in negative half cycle. For all the thyristors, I am considering firing angle alpha. In between 0 to pi, at an angle alpha, I am turning on the thyristor P1. I turn on the thyristor P1, the current flows from A to P1, P1 to C, C to R load to D. The input voltage appears across the load at an alpha, output voltage V0. At pi, P1 comes to natural commutation and stops conducting. I am firing thyristor after pi plus alpha, so in between pi to 2 pi. In between pi to 2 pi, I can turn on P2 and N1. So I am firing P2. Then current flows from B2, P2, C, R load to D. Here also the current direction is same. So even in negative half cycle, the current is flowing through the load from C to D is in one direction, that is positive direction. So I am considering this as positive. This is due to P1, this is due to P2. I need a frequency of 12.5, then half cycle should be up to 4 pi, P region. So again at 2 pi, at an alpha, I am again firing P1. Same thing happens and repeats. After pi, this is P2. So my half of the cycle is completed. Now this is from 4 pi to 8 pi. This is the reason where I turn on the N thyristors, or this is known as N region, at 4 pi to 5 pi. This is again a positive half cycle is there. In positive half cycle, P1 and N2 can be turned on. I turned on P1 while getting the positive half cycle. I need to get the negative half cycle, so I'm going to turn on N2 here. So in between this, current flow D2 R load to C to N2 to B. Here the direction of the current is from D to C, which is opposite to the previous one. So at alpha, if I turn on N2, the voltage appears in negative half cycle. This is due to N2. Now between 5 pi to 6 pi, the current flows from D2 R load to C. Here I'm turning on the N1 to A. Here the current flow from D to C at an alpha. This is due to N1. The same cycle repeats. In this output, to complete one cycle, it has taken 8 pi radians, which is 4 times more than the input supply. Input supply takes only 0 to 2 pi to complete one cycle. When the time period is increased 4 times, then the frequency is reduced to 1 by 4th time. So output frequency F0 is given by 1 by 4 times of source frequency Fs. Now this is how the cycloconverter works for step down. Now we have seen how this circuit step downs the frequency. Now the same circuit we use to step up the frequency. And we know that this is a 50 Hz supply. Now we want to step up to 100 Hz, which is nothing but the one cycle is completed in 2 pi radians. Here for 100 Hz, one cycle should be completed in 5, as frequency is inversely proportional to the time. In positive half cycle of the supply, P1 N2 or forward biased can be conducted. In negative half cycle, P2 N1 are forward biased and can be conducted. At 0, I'm turning on the thyristor P1, then the current flows from A to P1 to C through the R load to D. At pi by 2, which is in positive half cycle, I'm turning on the N2. Then the current flows D2 R load to C to N2 to B. You can observe the current direction is reversed here. Replicate the same thing in the waveform. Then at 0, P1 is turned on. Output voltage as same as the input up to pi by 2. Here at pi by 2, I'm turning on the N2 by turning off the P1 forcefully. The same voltage which is here flowing in the reverse direction here. So this is due to P1 and this is due to N2. It has taken only pi radians of the time to complete one cycle. So this is having the frequency of 100 Hz. At pi, I'm turning off N2 forcefully. I'm turning on P2. Current I flows from D to P2 to C through the R load to D, which is same as the direction of first case. At 3 pi by 2, I'm turning on N1, the current flows D2 R load to C to N1 to A. While turning on the next thyristor, the previous thyristor should be commutated or else should be stopped forcefully. Replicate these two in the waveform. This is due to P2 and this is due to N1. After 2 pi, the same cycle repeats. The output voltages. Now this is how a single phase center tapped or midpoint cycloconverter works for stepping up and stepping down the given frequency.